So as you see on the screen, we're going to talk about the virtual machines, and this is the agenda. Introduction to virtual machines, virtual machine file, properties of virtual machine, components of virtual machine, different ways of creating a virtual machine, Vsphere client versus the web client, right? Or different ways of accessing your ESX server and using it. These are the topics that I have for today's meeting. So let's quickly start with the virtual machine topics. Firstly, what exactly the virtual machine? What exactly the virtual machine? A virtual machine is a software computer that just like a physical server, it runs an operating system, it runs an application. Well, I mean, before we go to the virtual machine, maybe I can ask you some questions. Hope you all have understand the concept of virtualization. Why do we need it? Initially, I said for any company who need a website, who need an application, who need a software, who need IT support, they need a server. We talk about the hospital management system, right? And any example that you take in today's world, you need the IT. So IT is information technology. It is a generic word. So you need, if you need any application, the Uber car booking application that we use, right? That has to be installed on some server, some computer. So the computers where you install the server, if you give access to everybody, I mean, if you put that in a public place, everybody can access, and some may accidentally shut it down. So the users, when you try to book a Uber cab, as the server is down, is as it was powered off by somebody, you cannot access it. That's the reason we put such a computer in a secured place called the data center. Okay, and as the computer needs to be in power on state for 365 days, and it has to process a lot of requests every now and then, it has to be very powerful, and it has to have the reliable components. So instead of computer, we buy a uh, much more reliable piece of hardware that's called the server. So the servers are similar to your computers, but the servers are designed to perform a heavy workloads, and the durability, the redundancy, uh, right? It's a different level of planning altogether, different level of design. So we call it a server. Now, as it is designed with such kind of considerations, buying a server would cost you a lot of money. Buying a server will cost you a lot of money. That's the reason. Uh, that's the reason people, I mean, the company called VMware have invented a virtualization solution. So what virtualization will help you do is, on a single server, you will be able to create multiple virtual machines, and each virtual machine have its own operating system. Okay, on a single physical server, you will be creating, once you install the VMware virtualization operating system, that is your ESX or ESXi, that will give you an interface where you can create multiple virtual machines, and each virtual machine can have its own operating system, and each operating system can have its own set of applications, right? In that process of learning the virtualization, we have seen the introduction of virtualization, we have seen the ESX level topics, networking, storage. Finally, we are at a level, or we are at a stage understanding the virtual machine. So like I said, on top of the ESX server, you will be creating the virtual machines. What exactly the virtual machine? A virtual machine is a software computer that is just like a physical server or a physical computer. It runs an operating system, an application. The virtual machine is a set of configuration files. Okay, a virtual machine is a set of configuration files. For example, in physical server or in your computer, you will have hard disk, you will have SCSI cable, you will have motherboard, you have BIOS, right? So there are different physical components. In virtual server, all these files are comprised or composed as a file. All these devices, the hard disk, SCSI cable, whatnot, everything, the motherboard, all the physical components that you see, the CD-ROM, floppy drive, right? All these devices or network interface card are composed as a file. So a virtual machine is a software computer that acts like a physical server. It has an operating system, it has an application. A physical server is a set of files, okay, that act, I mean that will, those set of files will give you a functionality of virtual machine. As you see on the screen, there are a couple of files that actually make the virtual machine. VMX file, VSwap, VMDK, VMSD, VMSN, log file, and VRAM file. So there are a couple of files. Let's see one after the other. Guys, don't confuse. A virtual machine is a software computer, right? It is made up of some files. The physical server would have the physical components, your hard disk, your motherboard, your BIOS file, I mean your BIOS, your CD drive, your floppy drive, SCSI cable, all that. In a virtual server, all those physical components are the files. So the VMX file is the most important file, that is a configuration file, a virtual machine configuration file. So whenever you create a virtual machine, whatever the configuration that you give to the virtual machine, let's say 2 GB RAM, 1 CPU, 1 network interface card, 20 GB hard disk, 2012 operating system, blah blah blah, all that configuration will fit into a text file called VMX, a virtual machine configuration file. And the next one is Vmdk. There is a concept called template, right? We all are aware of it. When I have to, maybe when I'm getting a call, I have to, if I have to reject the call with a message, I say, hey, I'm in a meeting, I'll call you back, or I'm driving, I'm sleeping. Uh, so that is a template that was already composed in your mobile. Similarly, instead of you creating the virtual machine again and again, installing the operating system inside it, you can actually make some standard templates. So whenever there is a similar requirement, you just can, use this base template to create the virtual machines. So we will have a dedicated class talking about the templates, but for now understand vmtx is a template file. And nvram file, nvram is actually a BIOS file. Okay, BIOS file. I believe you all know what is the functionality of BIOS. The BIOS is the basic self-test. Okay, once you power on the server, the BIOS will does a self-test of all the attached components. If the attached components are working or not, or connected or not, if it finds any problem with any of the components, then it will not proceed with the boot process. You will see a blue screen coming up, system cannot boot or XYZ stuff. Vswap is actually the swap file. It's actually a temporary space on your hard disk which will be used as memory. Log file, whatever you perform on the virtual machine will be captured into this particular log file. Vmdk, which is a hard disk file. If it is a physical server, you will have a hard disk. If it is a virtual machine, you will see Vmdk file. And in Vmdk, there are three types of Vmdks. Flat.vmdk is actually the disk where you have the data stored. Vmdk, just the Vmdk is a descriptor file, which is a plain text file which has the information about the hard disk, maybe the blocks and sectors, the addresses and all that stuff. Okay, so just the Vmdk is a descriptor file. However, flat.vmdk is the data file where exactly the data is stored. RDM is advanced concept. I mean I don't want you to put into the confusion, just ignore it. Delta, VMSD, VMSN or the snapshot related files. When we go to the snapshot topic, I'll talk about it extensively. So for now, just see VMX is a configuration file, VMTX is a template file, NVRAM is a BIOS file, VSWAP is a swap file or a page file, log, VMDK, flat.vmdk. These are the files that you need to remember, and you should be able to tell the same what did I say now to the interviewer if at all somebody asks you. The virtualization properties. So the virtualization, I mean the virtual machine is isolated. Okay, it's like I said the other day, if there is a ESX server on top of it, if there are 10 virtual machines running, each virtual machine run its own isolated space. Its own isolated space. It doesn't require. Or it the other. I mean, no two virtual machines will get to know that they are running on the same hypervisor. Okay, they are completely isolated. For example, if you see on the screen, if this is your ESX server and there is a mission 1, mission 2 and mission 3, mission 4, all these 4 virtual machines are running completely in isolated state. Mission 1 will never get to know that mission 2 is also running on the same ESX server. Mission 2 will never get to know mission 3, 4 and of course mission 1 will never get to know that there are 3 other missions running on the same hypervisor. So the other 3 right? Mission 4 will never get to know that there are other 3 virtual machines running on the same ESX server, completely isolated. And there is encapsulation. You can capture the entire state of a virtual machine in the form of snapshot or the cloning. So as we progress in the class, maybe tomorrow or day after tomorrow, when we go to the snapshots or the cloning state, you will get to know that the state of the virtual machine, the current state of the virtual machine, can be captured in the form of a snapshot or in the form of a clone copy, so that it is very easy way of taking the backup, okay, in case if you are planning any activity. And it is portable because you just can take the entire virtual machine to a pen drive, take it to any country, upload it, and it start works for you. And you can actually add and remove the resources as and when you need on the fly, if you need. So this is again an advanced level diagram. I don't want to put you into the confusion, because this is explaining you how the IO is processed. When I say IO, it is input output operation to the storage or to the network, how the IO is processed by the host, by the virtual machine, and all that stuff. Just ignore it. The same thing here. Well, the virtual machine components, the same that I said, you can see on the screen. You have the parallel port, you have serial port, you have the USB port, you have floppy drive, mouse, keyboard, network interface card, SCSI controller to connect your hard disk, processors, memory, a VGA card, and your CD drives, right? So these are all the components of your virtual machine. So the same components can be seen on a physical server as well. If somebody asks you, you just can say the same components that you see on a physical server. It really doesn't make any difference. Okay. And finally, the Vsphere client versus the web client. Like I said, starting Vsphere 5.0, VMware is not developing the Vsphere thick client. So the client that you are currently installing on your desktop, right? That client is not, is not being developed. They're just continuing it, and in 6.5 they officially announced the client is no longer available. Okay, so in 6.5. So that's the reason if you are working on 5.0, 5.1, 6.0 or 6.1, whatever the new features those were introduced in the respective versions are only available in Vsphere Web Client, but those are not available in your Vsphere uh, thick client. When I say thick client, that the client that you install on your machine. Okay, so this is the only difference. Though there is a lot of write up on the screen, only difference you can understand is the Vsphere. There are 2 clients, like I said, the Vsphere client, the Vsphere web client. Web client is nothing but the browser. Okay, the Internet Explorer, Google Chrome, whatever it is, you just open it up, put your server details in there, so that the new features are only available in your Vsphere web client. However, the Vsphere client is actually a C# developed application that is available, that can be downloaded from the internet, like how you have done, and you can install it on your machine, so that you can, that's of course the traditional way of accessing the environment. We all the virtualization engineers got used to it. We have been using it. But now with Vsphere web client, you don't have to install anything. It is just uh, the Vsphere, sorry, you don't have to install anything. You just open up the web browser, put the server details in the address bar, and start using it. That's easy it is. Okay, so, and like I said, the advanced features are only available in your web client, not in your C# client. So that's the theory. Let me quickly take the console of our server. Okay, so there are three type of hard disks in virtual machine. So for you to understand the thick provision, lazy zero, thick provision, easy zero, thin provisioning, you need to understand in general what will happen when you write some data. Let's say I am typing something here. So when I type this message on my notepad and I say Control S, this data, this digital information will go get stored in form of zeros and ones on the hard disk is what we know. But at the hard disk level, the operating system, what it does is, for example, if it occupies the first 10 blocks, the moment you try to write this data, it has to occupy the next couple of blocks, maybe 11th and 12th block, okay, space on the hard disk. Once it occupy the next blocks, it zero out the data, zero out the blocks, meaning whatever the blocks that you occupied, the 11th and 12th, it will completely write zero into those two blocks, and then uh, data will be written into the blocks. So this is the process that will happen. This is the process that will happen when you write something into the hard disk. The moment you say you write anything, I am saying I am typing something here, and you say Control S. When you say that, it has to go to the hard disk, occupy the next blocks, and zero out the blocks. Then actual data will be written. So when it comes to the thick provision, lazy zero, thick provision, eager zero, and thin provisioning, let me tell you this. Thick provision, lazy zeroed, or thick provision, eager zeroed, thin provisioning. First is thin provisioning. So thin provisioning is dynamically occupying the space on the HDD, that is hard disk, dynamically occupying the hard disk, meaning, for example, if I create, I'm going back here, as you see on the screen, at storage, as you see on the screen, currently it has got 980 GB of free space, 18 GB of free space. If I create a hard disk that is of 900 GB, you can see here it is SAN04, okay, SAN04. And if I choose thin provision and if I create 900 GB, it will not occupy 900 GB. Let me go there. I just say finish. That will create a virtual machine here. So virtual machine test that we've created, it is on SAN04. Okay. If I go here, if you see, the free space is still 914 GB. It is still 914 GB because you see here virtualization properties, the provision space is 916 GB. However, the used is 1.58 KB because there is nothing stored. There is nothing stored. So in thin provisioning, it dynamically occupies the space on the hard disk. So on this 900 GB that you provisioned, nothing is occupied. If you start uploading the data into it, maybe some 10 MB, 20 MB, some 100 MB, as you keep adding the data, that's when the data will actually occupy the actual space on the hard disk, right? So that is dynamically growing the space on the hard disk. So first it has to occupy the blocks. In this, what it has to do is occupy the blocks. Second thing, zero out the blocks, meaning write all zeros into the blocks. Third, write the actual data into the blocks. So there are 3 steps involved in thin provisioning, whereas in thick provisioning, in both the thick provisioning, the moment you create a hot disk, for example, let me go here the same way. As you see on here 918 GB free, I'm going to the same virtual machine here and I'm trying to add a hot disk, create a new hot disk. So this time I'm choosing a disk space of 100 GB. Okay, so this is lazy zeroed is what I choose. So next I'm just creating 100 GB of space. So this time it will go occupy that 100 GB. You see the free space turned to 818 GB. You saw that 880 GB and the user space is 100 GB now. We did not store anything but still it occupies that space. So here the moment you create the disk, it occupies the complete uh, occupies the space when you create the disk. It occupies the space when you create the hard disk. And then the steps that are involved to write the data into the hard disk is this. It zero out the blocks, it writes the data into the actual block value. Right? When you try to write the data is what these 2 steps involved. Well, the third one is it is also similar to your thick provision, but in lazy zeroed, sorry, I'm so sorry guys, it is for your eager zeroed, sorry, for lazy zero, when you create the hard disk, it occupies the space. Okay, and the next 2 steps that are involved when you are about to write the data, this is what happens. And when you actually create a hard disk that is of eager zeroed, it occupies the blocks and it zero out the blocks as well. So it occupies the blocks and it zero outs the blocks as well. So the only step that is involved here is step 3, that is writing the actual data into the blocks. Let's go here, try to create a hard disk. You can see here in the earlier situation, when I create the hard disk or when I create a virtual machine, it happened immediately. But when I try to create a eager zeroed hard disk, 100 GB, I see a eager zero hard disk. Next, finish, say OK. Then it will take a lot of time. You can see here it will take a lot of time because it is zeroing out all the blocks. Zeroing out all the blocks is equals to writing 100 GB of data into the hard disk. So you can imagine now it takes a lot of time. I mean, it will take at least the time that is required to write 100 GB of data. The moment it is done, you will see the free space available is 718 GB because 100 GB of hard disk is being created here. Getting me? So when you create a hard disk that is of thin provision, it has got 3 tasks to do whenever you write a data into the hard disk. When you create a thick provision lazy zeroed, it has got 2 tasks to do when you're actually writing the data into it. When you create a thick provision hard disk that is of lazy eager zeroed, it has got 1 task to do when you actually write the data. However, while creating the hard disk, it takes a lot of time because it has to zero out all the blocks. You still can see here the hard disk is being created. In other examples, the task was immediately done and you have seen the effect coming here. but now it is still 22%. Okay, so depending upon the usage, you may have to choose which hard disk is actually well suits you, which hard disk is suits you. And once, while some activity is going on, you can see in the active tasks of the virtual machine, reconfigure virtual machine, there is a task that is going on, active task. So while there is an active task, you cannot do anything else. You can only do one task at a time. While there is something happening, you cannot do a second activity, or you cannot initiate a second activity. Okay, so so normally the use cases for it is, so use cases for lazy 0 days, for all production for all production servers. Here the use case is for IO sensitive applications, the application that cannot tolerate any latency, which need to be processed within milliseconds or microseconds. That's when you go for the thick provision easy 0, because the write is very fast. Use case is non-critical or non-production servers, right? So this is about your hard disk types, and you saw how to create a virtual machine, and this is done. You can see that is 718, and you just have to go to edit settings here, you go to CD drive here, and go to data store, map your ISO file, the file that you downloaded, if you remember 2012, and you just power it on. It should install your operating system. Okay, you power it on. You either can go to console here, so that it gives you the direct console. So in our example, I do not have the ISO file mounted, otherwise I would have seen the boot console. Or you just can right click on the virtual machine and you say open console, so that a pop-up window will come out, and you can see what's happening in there. Okay, so this is it for today, guys. I would request all of you to go ahead and practice the virtual machine creation. Ask me the doubts if you have any.